All right, for those of you who had trouble with today's quiz, I hope this will help for your retake, which will be hopefully as soon as possible. Okay, first, what we are asked is plot these 2 points, A and B. -4, -6. Let me scroll down a little bit. -4, -6. Let's call that A. And -1, 3, which we will call B. And it says calculate the slope between them for segment AB. Okay, so we need to draw a line. Well, we could use a slope formula, but when we have a graph like this, I think drawing a line would be better. Let's get that tool out. This straight line tool. There we go. That's good enough. So then, in order to do that, I could either draw one big slope triangle like this, if I wanted to, or I could find other points along the way and make a smaller slope triangle. These are the only 2 other points I see along the way. But let's do this big slope triangle in case we have a harder example next. Let's see how many points we go up. Our slope is rise over 1. This line's going up, so it's going to be a positive slope. 1, 2, 3, 4, 5, 6, 7, 8, 9. So rise over run equals 9 over, and sorry, I went a bit over a little bit. So to the right, we're going 1, 2, 3. 9 over 3. So the slope's 9 over 3. That simplifies to 3 over 1, or just 3. Okay, knowing this, we are then asked to find the equation of the line y is equal to mx plus b, created by this segment. Well, this equation is what we call slope-intercept form, and all we need to know are 2 things. Well, this value m is the slope, and this value b is the y-intercept. That just means it's the point at which our line would cross the y-axis. When does it touch or cross the y-axis? Well, this line doesn't do that right now. But what we can do is just, this thing is getting close to it right now. We can just extend that line, see when it touches that. So let's do that. If I were to continue it, there, it would touch at 6. So we could just, using this graph, say, okay, if we know the slope is, in this case is 3, and it touches at 6, we would plug those in. 3 is equal to m, 6 is equal to b. So we'd say y is equal to 3x plus 6. I think a lot of you put 5 there, which I mean, I'll accept. That's just, a human error. There's another way to find this if we didn't have the graph. If we had the slope, y is equal to 3x, but we didn't know the intercept, we would write an equation like this, where since b is unknown, b is not a variable, but it's a constant, but it's an unknown. So we're going to write this equation like this. We have 2 points on this line. That's effectively 2 solutions to this equation, 2 xy solutions. So what I'm going to do is say, in this case, -1, 3. Let's plug that in for x and y. So in this case, 3 will be equal to 3 times -1 plus b. Well, that means 3 is equal to -3 plus b. So when we add 3 to both sides, we get 6 is equal to b. So that's another way of getting 6, but as our y-intercept. That's what our equation would look like. All we need is the slope and the y-intercept. Okay. We are then asked, write the equation of a line that's parallel to this. Well, what do we know about parallel lines? They have the same slope. They will never touch. We aren't told anything else. We don't say, oh, let it go through this point. Just give me a line that's parallel to it. Well, I think the easiest line to do is one that has a y-intercept of 0. So we know our slope is going to be our slope's going to be 3, so y is equal to 3x. If it was going to go through the origin, that y-intercept would be 0, so I can do y is equal to 3x plus 0, or just keep it as y is equal to 3x. So then it says, let's draw that line. Okay, let's go ahead and do that. And let me extend it the other way. There we go. Just like that. We're close enough, you know? All right. So now we're asked, find and plot this point C, where C is going to divide this, our line AB. Let's go back to our points. Whoops, I need to erase a little bit. So I need to find the point C. So it'll divide AB into 2 sections. So like if we have AB, then I want point C to divide that such that the ratio of, this is AC, of AC to CB is 1 to 2. So that means this CB or BC segment is going to be twice as long as this AC segment. So I have to find a point that divides this thing in that kind of way. Well, there are 3 effective units here, right? If this is twice as long as that, 1, 2, 3, I needed to find the point that divides this 3 ways, right? What I do then, and this is what your retake is going to be like, is it's going to be on a exact coordinate. It's not going to require anything more than that. So what I want to do is find all the points that I can find where it just lands on a point. Well, let's see. 1, 2, 3. So this is, if this is a length of, let's call this K, this length is K, and this length is K. So from here to here, we have the length of K, and from here to here, we have twice that length, right? From K to 2K. I just inserted a letter into that. This length here is twice the length of this guy, and this point divides that. So the point is -3, -3. Okay. Now it says write the equation of a line that is perpendicular to AB that goes through this point, and then plot it. Okay, if we have line AB, which is 3x plus 6. We want a line y is equal to mx plus b that's perpendicular to this. If it's perpendicular, this slope is going to be different. That slope is going to be the opposite reciprocal. We have to remember that. So the opposite of 3 is -3. The reciprocal of 3 is 1/3. So we're going to have the slope of -1/3. So we're going to have y is equal to -1/3 x. It's not going to, I don't think it's going to be +6 though. We are told it's got to go through this line. So if it goes through this line, I'm going to leave this as a plus b right now because we need to figure out what that b is. And just like with before, if we're told that 0, 2 is a point on this line, then 0, 2 is an xy solution to this equation. It is a point on this line. So I'm going to plug in x and y to this equation. So 2 is equal to -1/3 times 0 plus b. Well, -1/3 times 0 is 0. So we get 2 is equal to b. Well, that's convenient. So our equation is y is equal to negative 1/3 x plus 2. And let's graph that. So it's going to go through this line here. Let me erase these k's. It's going to go through this point here, and it has a slope of negative 1/3. So that means I'm going down, but my rise, my decrease in rise is 1 every time I go over 3. I'm going to be going down 1 over 3. Let me just, so I got that there. Let me just increase the length of it. Something like that. Last one. This should have been listed as like number 2 instead of, because it's separate. Are the lines given by these equations parallel, perpendicular, or neither? And we got to show work. So to determine these, we want y is equal to equations. Y is equal to mx plus b. So with this guy here, to get mx plus b, I need to subtract 2x from both sides. So then we get y is equal to 7 minus 2x. Well, that doesn't quite look like mx plus b. It looks a little bit different because the x part is to the left. So what we can do, if it makes it easier for you, is we can just rearrange them. This minus 2x I'll put first. This 7 I'll just put as a plus 7 afterwards. So we have minus 2x plus 7. This other one, let's take a look at. 14y is equal to this. Well, if I have 14y and I want to just remove that 14 multiplier to it, I'm just dividing everything by 14. Everything by 14. So we'll get y is equal to 15 over 14x, or sorry, 15 over 14 minus 2x. So this again is reversed. We need to, for convenience, we need to put the x first. Sorry, someone came in, I was distracted. So we have, so I'm going to just rearrange these. Negative 2x plus this wacky fraction 15 over 14. Don't let this fraction scare you. This is the y-intercept. For parallel lines or perpendicular lines, we are worried about the slope. Here we have the slope of negative 2. Here we have the slope of negative 2. These lines are parallel. They have the same slope. Really hope this helped. We will have a reassessment on this very soon.